First example. Even before you start, you should look at the right-hand side and ask yourself, well, is that positive? Well, if it is positive, then things are straightforward. You would get an answer that is over. Yes. 1. If it is negative, it means whatever answer that you have is between 0 and 1. Good. So you can guess even before you start. So here, do we expect it to be greater than 1 or between 0 and 1? Greater than 1, right-hand side is positive. And if you have just one term, logarithmic term on the left-hand side, or any side for that matter, you can simply exponentiate on both sides. What does exponentiation mean? You're raising it to the power of a base. In this problem, which base would you choose? E, 10, 2, 14. 2. Riley, can you hear him? I didn't ask you, can you hear Nolan?
No.
No.
2. I was unsure.
Now are you sure?
No.
No. 2. Y2, the base here is 2. So we are going to raise it to power of 2 on both sides. Just like when you take the square root, you take the square root on both sides. If you square on both sides. If you take logarithm, you take logarithm on both sides. So both sides we exponentiate to the power of 2. That will get cancelled because 2 raised x and log base 2 of x are what of each other? Inverses of each other. So quickly, we'll have 7x equals 512. Divide by 7 on both sides. It is approximately 73. Is that number bigger than 1? Yes, one would hope so. Now, in this case, the answer will be greater than 1, but you do have to keep in mind, sometimes you will get an answer, but when you plug it back in, it won't work. So when it comes to logarithmic equations, you should always be careful, because you may do everything procedurally correct, but you would have an answer that's not valid. So be careful. The answer here has to be 32.67 approximately. What base do we have on the left hand side? 10. So we have to exponentiate on both sides using what power? 10. Quickly, those two would go away because they are inverses of each other. 3x plus 2 would equal 100. 3x 100 minus 2, 98. X 98 divided by 3, which is 32.6666. Approximately 32.67. You can just leave it as 98 divided by 3 as well. Are we clear? What is the very first step in this problem? What comes to mind? get rid of the what? Log first. So you may be tempted to take the square root because you see a square. Don't. We save it for later. You get rid of the log first, bring the term that's inside, and then you can take the square root. So how do we get rid of the logarithm? You raise it to the power of 2 on both sides. What would happen to those two terms? Which would mean 4x plus 5 squared would equal to 16. Now we can take the square root because we want to get to x. So if you take the square root on both sides, square root and square will get cancelled. Why? Because square root function is the blank of square function.
The inverse.
The inverse. So those two would go away. 4x plus 5 would equal 16. Technically speaking, it is plus or minus 4, that line. Was too quick there. So there are two possibilities, plus 4 and minus 4. 4x would equal to move the 5 to the other side, 4 minus 5, negative 1. Same, move it to the other side, negative 4, negative 5, get negative 9. Divide by 4 on both sides, negative 1 over 4, negative 9 over 4. So I have two solutions. Both of them are negative. Could I say that those are valid solutions because I got a negative answer? Very good. Let's say no, but earlier today I mentioned if you just have log and x and you have another term that is negative on this side, then that would be a problem. Likewise, if you have log some term here equal to some other number, but if that becomes negative, that's a problem. But here, no matter what x you plug in, may it be negative 1 over 4 or negative 9 over 4, just square it. So that term will always be positive. So you can easily take the natural logarithm of a positive number and things will just work out fine. So the first possibility there, you plug in negative 1 over 4, that would become 4 squared. Yes, which will give 4. Likewise, negative 9 over 4, which will still be 4 squared. You'll get 4. Good. So the key takeaway here is just because you have a negative answer doesn't mean that it will not be a solution. Sure, anytime you have negative answers, you've got to be cautious. Well, you've got to be cautious even with a positive answer because it has to satisfy the equation. Erase. So, most of you got the exponentiation part, we're raising it to the power of 3 because we see log base 3 is great. And this is something that I expected, which is why it's part of this problem, or I gave you this problem. Exponential on both sides, raised to the power of 3. Squiggly. And 27 on this side. X plus 4 minus x on that side. X's will get cancelled. 4 equals 27. Not possible. So no solution. But that is incorrect. Why? Life's not that easy. You can't simply exponentiate things individually. So we have to use a property, and it goes back to what I said at the beginning of class, the very first problem. I said you have to have log by itself on the left-hand side, another term by itself on the right-hand side, you exponentiate. That is not the case. I do have logarithms, but it's not a single logarithm on the left-hand side. There are 2 logarithms. So the goal is to combine those 2 logarithms and come up with 1 logarithm of base 3. Well, what property could we use? The quotient rule. What does it state?
Log of a number over, log of u over u goes to log of u minus log of g.
Good. So if we use the quotient rule, this came, if that is u and that is v, log base 3 u divided by v would give you this. So I have a log by itself on this side and 3 on the right hand side. Now I can exponentiate and free the term that is trapped inside the logarithm. So 3 log base 3, x plus 4 divided by x. 3 raised to the power of 3. Strangely, more than one person wrote that as 9. I don't understand why. 3 raised to the power of 3 is 27. Those 2 will get cancelled. We have x plus 4 divided by 4. X plus 4 divided by x equals 27. Another thing that I expected some of you to do, because it happens naturally. I've seen students in calculus 2 or differential equations make this mistake. Don't do it. Oh, it was 27. No solution. No points to you. That is not correct. Why? X is the common denominator of the 2 terms in the numerator. And I raised it. So algebraically, that would equal to x over x plus 4 over x equals 27. Yes, common denominator of x. You can cancel these 2 now. 1 plus 4 divided by x equals 27. 4 divided by x equals 27 minus 1, 26. 4 would equal to 26x. You're multiplying by x on both sides. X's will cancel here. You get 26x. Divide by 26 on both sides. 4 over 26 would equal to x. I have a 2 in common. So get rid of 2 here. you will get 2. Get rid of 2 in the denominator, you'll get a 2. So there is nothing wrong in exponentiating the very first step, raising it to the power of what base? 5. Nothing wrong with it, but I'm going to show you a different approach so that we use the property of logarithm. So log base 5, y root is nothing but 4x plus 3 raised to the power of 1/2. If it is cube root, what would you raise it to the power of? 1/2. 16 through 1/16. What rule can we use? Our rule, move that 1/2 to the front. You'll have 1/2 times log base 5 for x plus 3 equals 2. We can't simply raise it to the power of 5 yet. Why?
The 1/2 is that.
The 1/2 is in the middle. You should have logarithm by itself on this side, one single logarithm for us to exponentiate and get rid of it. That's not the case. How do we eliminate that? 2 in the denominator, multiply by 2 on both sides. Log base 5. Or 4x plus 3. 2 times 2 would be 4. Now I have the logarithm by itself on the left hand side and a number. Base 5 exponentiation on both sides would result in 5 raised log base 5. 4x plus 3 equals 5 raised 4. What happens to 5 and log base 5? It's quickly. So 4x plus 3 would be equal to 625. Subtract 3 on both sides. 4x would equal to 622. Next step, you divide by 4 on both sides. 622 divided by 4, which would be 155 into 5. Okay. When we were, any questions before? Good. When we were doing exponential equations at the very end, I started or I did an easy problem, a trick problem, and then we did a complicated problem, very end, which involves substitution. With logarithm, sure, we can do substitution, but it could get challenging. But there is another type which I'd like to do. I'm going to start with the easy case. Log base 2 of 3x minus 2 equals log base 2 of 4. Good. How would you go about doing it?
Subtract the log, or like that equal to 0.
Subtract the log, set it equal to 0. Sure, but one of many ways.
They just cancel each other. Because they both have the basic log 2.
I see what you're saying, but it's not counting. That you're just using the wrong terminology. But you are correct. If you recall, last time when we were doing exponential functions, I did on the side here. We simply set the powers equal to each other because one exponential term by itself, another exponential term by itself, base is large, so I just equate the powers. Same logic, both logs are of the same base. All you have to do is set the arguments equal to each other. So 3x minus 2 would equal to 4. Move the -2 to the other side. 3x would equal to 4 plus 2, 6. What is the next step? Divide by 3 on both sides. X is 2. Okay, so very first step, you can't simply exponentiate the power of 4 on both sides because we don't have log by itself. So we have to use the properties of logarithm, combine somehow, get it to a single logarithmic function. I see, of course, the bases are identical, which is key. Otherwise, this would be painful. So bases are identical. So log base for u plus log base for v is log base for u times v. X minus 2 times x minus 4. And that would equal to log base 4 of x plus 1. Now we can use the logic from the previous problem. If you have the same bases and if both sides have logarithms by themselves, you can simply set the expressions inside the logarithm equal to each other. So left hand side, x minus 2 times x minus 4. Right hand side, x plus 1. Foil, x squared minus 2x minus 4x plus 8 equals x plus 1. Well, we can move all the x's and the numbers to one side to get an equation. So minus 6x, x moves to the left hand side, minus 6x, minus x, minus 7x. 1 moves to the left hand side, becomes -1, 8 minus 1, 7. In my mind, as I was doing, I put -7. And that's how we got 77. So, what type of equation is that? What?
A quadratic.
A quadratic equation, because left hand side is a quadratic function. As I went around, so you made a good point. Well, I could use the PQ, approach and determine the roots. Sure, you can, but it's just too much work. Right? Do we want to complicate this problem? No. So if you observe that is a quadratic function, how do we solve a quadratic function? Sure, that is the last resort before that. But if you can't factor, factoring is the easier way. But can we factor this? No. So quadratic formula. A is 1b, -7, c, 7. Left hand side is a quadratic function. So if you graph it, would it open up or would it be open down? Why open? Because A is positive. If it is open up, would it have a minimum or a maximum? Minimum. Okay. Formula minus b, so minus of -7 plus or minus b squared minus 7 squared parentheses beta minus 4 times a times c divided by 2 times a 1. 7 plus or minus square root of 49 minus 28 divided by 2. 49 minus 28 is 21. So we have two solutions, yes. So the two solutions are 7 plus square root of 21 divided by 2, 7 minus square root of 21 divided by 2. Now, in a problem like this, you have to check if both of them are valid solutions. Going back to the original problem, I had log base 4 x minus 2, log base 4 x minus 4 equals log base 4 x plus 1. That was the original equation. Yes. We have to make sure that both solutions that I have will satisfy that equation without any issues. Issues in the sense you don't end up getting a negative number and you try to take the logarithm of a negative number. So right hand side is not going to cause a problem as of now with that root. Square root of 21 is about 4.6. You can use your calculator. So that entire term is approximately 11.6. 5.8 something. Yes. This would be 7 minus 4.6, approximately 1.2 something. So what do we get exactly? So I'm thinking 5.8, 1.2, approximately.
Less than 4.
Less than 4.
For the
No. What are these two?
5.79.
5.79 and
1.21.
1.21. 5.79 will work here. Yes? Will work there. Will work there. Do you agree? Because 5.79 bigger than 2. 5.79 bigger than 4. No problem here. 5.79 plus 1, 6.7. No issues. Second root, 1.21. We'll plug in 1.21 here, it will work. But 1.21 minus 4, you get a negative number. 1.21 minus 2, you'll get a negative number. One might say, well, I have negative numbers, I can't take logarithm of a negative number. That solution will not work. Sure, that is kind of true. 1.21 will give a negative number, but why should you take log? Yeah, if that is negative, that is negative. When you multiply using properties of logarithm, negative times negative is positive. Can I take logarithm of that positive number? Yes. Good. So even though in this problem that seems to present an issue, it's going to go away when you multiply those two. Does that make sense? So negative times negative in this problem, perfectly fine. Positive times positive, perfectly fine. But if you end up getting positive and negative, problem. Good. So here, both of them are proper solutions for that equation. Good.